Our familiar star, a cosmic furnace, our sun. A blazing ball of plasma, the anchor of our solar system. It bathes us in warmth and light, the lifeblood of our planet. We take it for granted, this giant furnace in the sky. But what if I told you, our sun could be something entirely different, something far more exotic, far more powerful, something like a pulsar. Imagine a summer evening, the sky ablaze with the colors of a setting sun, that familiar warmth on your skin. All thanks to nuclear fusion, the sun's powerhouse. Deep within its core, hydrogen atoms fuse into helium. This process releases the energy that sustains life on Earth. It's a beautiful, elegant process, one we often overlook in our daily lives. But the cosmos holds many secrets, many wonders that dwarf even our own star. And among them are the pulsars. These are not your everyday celestial objects. They are the remnants of stars much more massive than our sun. Stars that lived fast and died young in spectacular supernova explosions. Pulsars are fascinating objects. They are like cosmic lighthouses, sending out beams of radiation that sweep across the universe. Imagine a beacon, cutting through the darkness, a silent testament to the power of the cosmos. That's a pulsar. Pulsars are not just any remnants, they are neutron stars, the collapsed cores of massive stars. These stars, unlike our sun, lived short, intense lives, ending in a brilliant supernova explosion. What remains is a sphere of unimaginable density. Imagine cramming the entire mass of our sun, all that matter, into a ball the size of a city. That's the density of a neutron star, a teaspoonful of which would weigh billions of tons. This incredible density also forces the neutron star to spin rapidly, some making hundreds of rotations every second. But there's more. These spinning neutron stars possess incredibly strong magnetic fields, trillions of times stronger than Earth's. These fields funnel charged particles from the neutron star's surface, creating beams of radiation that sweep across space. These beams, like the beam of a lighthouse, are what we detect as pulsars. As the neutron star spins, its beam sweeps past Earth, creating a pulse of radiation. It's like a cosmic clock, ticking away with incredible precision. Now, let's indulge in a hypothetical scenario. What if, in a cosmic twist of fate, our sun was suddenly replaced by a neutron star, a pulsar? The consequences, as you might imagine, would be nothing short of catastrophic. First, the sheer difference in size. Our sun is a giant, over 100 times wider than Earth. A neutron star, in contrast, is minuscule, barely the size of a city. If the sun were to be replaced by a pulsar, it would be like swapping a giant beach ball for a tiny marble. Then there's the gravity. The sun's gravity holds our solar system together. A neutron star, despite its size, has immensely stronger gravity. Its gravitational pull would be over 2 billion times stronger than the sun's, throwing the entire solar system into disarray. But the most significant difference lies in their energy output. While the sun bathes us in a continuous stream of light and warmth, a pulsar emits intense beams of radiation. These beams, while fascinating to astronomers, would be deadly to life as we know it. Section 4. Immediate chaos. The solar system in disarray. The moment our sun transforms into a pulsar, the solar system would descend into chaos. The planets, no longer held in their stable orbits by the sun's gravity, would be at the mercy of the pulsar's intense gravitational pull. Imagine planets, once serenely orbiting the sun, now being tugged and pulled in unpredictable directions. Some might collide, creating cosmic fireworks of unimaginable scale. Others might be flung out of the solar system entirely, lost in the vast emptiness of space. But the chaos wouldn't end there. Remember those intense beams of radiation emitted by the pulsar? These beams would sweep across the solar system, sterilizing everything in their path. Planets, moons, asteroids, all would be bathed in deadly radiation. Earth, our home, wouldn't be spared either. The moment the pulsar's radiation hits us, our atmosphere would be stripped away, our oceans boiled off. Life, as we know it, would cease to exist in an instant. Section 5. A bleak future, Earth under a pulsar's reign. Even if, by some cosmic miracle, Earth survived the initial chaos, our planet would become a shadow of its former self. The pulsar's intense gravity would lock Earth in a synchronous rotation, meaning one side would always face the pulsar, while the other would remain in perpetual darkness. The side facing the pulsar would be a wasteland, scorched by the relentless radiation. The other side, locked in perpetual darkness, would be a frozen wasteland. Life as we know it would be impossible on either side. And let's not forget the pulsar's radiation. Even if some life forms miraculously survived the initial blast, the continuous bombardment of high-energy particles would be too much to bear. The radiation would mutate DNA, disrupt cellular processes, and ultimately render Earth sterile. In essence, our vibrant, life-filled planet would transform into a desolate, lifeless rock, forever trapped in the deadly embrace of a pulsar. Section 6. Life Beyond Pulsars, a Cosmic Perspective. This hypothetical scenario, while grim, highlights the delicate balance that allows life to thrive. It underscores the importance of our Sun, a relatively stable star, in the grand scheme of things. It also makes us appreciate the rarity and preciousness of life in the universe. But the universe is vast, teeming with billions upon billions of stars. And while pulsars might not be ideal for life as we know it, who knows what strange and wonderful life forms might exist in the universe, adapted to environments we can't even imagine. Perhaps there are life forms that thrive on radiation, that draw energy from the intense magnetic fields of pulsars. Perhaps there are life forms that exist in dimensions we can't even comprehend. The possibilities are endless. The point is, the universe is full of surprises. And while we might not find life as we know it on planets orbiting pulsars, that doesn't mean life doesn't exist out there in forms and shapes we haven't even begun to imagine. Section 7. Conclusion. A universe of wonders. So what if our Sun became a pulsar? The answer, as we've explored, is quite simple. It would be the end of life as we know it. Our solar system, our planet, our very existence all hinge on the delicate balance provided by our Sun. But this thought experiment shouldn't fill us with fear. Instead, it should inspire awe and wonder. Awe at the sheer power of the cosmos, at the incredible objects that exist beyond our little corner of the universe, and wonder at the possibility of other life forms thriving in environments we might consider hostile. The universe is a vast and mysterious place, full of wonders waiting to be discovered. So the next time you look up at the night sky, remember the pulsars, those cosmic lighthouses, and let your imagination soar with the possibilities. Who knows what other secrets the universe holds waiting to be unveiled?